Welcome everybody to our second event from Optimization for All. Christina and me are really happy that so many of you appeared today. Today our topic is about open source solvers, and we want to talk a bit about how we can make them better and also make them more known. And for this we invited three great guests. The first is Julian Hall. He's a lecturer currently in Edinburgh, and he's the founder of the Solver Hikes. Then we have Ted Rolfs. He's also an open source enthusiast and also a professor, and he is a co-founder of CoinOR, a library for many different kind of optimization problems. And then we have Geoffrey De Smet, who is the founder of Timefold and a specialist in planning and scheduling software. The session today is recorded, so if you don't want to appear in the video, then please turn off your camera. And you have the chance to ask your own questions. We have prepared like 30 minutes of questions from ourselves. And if you have any question, drop it. You can directly write it in the chat and we will later ask them if there's time. Otherwise, feel free to reach out to all of them. They are happy to answer all your questions. The moderation today is me doing together with Christina, and we have also two people who are doing like the production of the videos, which is Siva and Prachit. So many thanks also to them. And then if we go to the next slide, we see the current agenda. So we will have like a short introduction of our platform, Optimization for All. Then the guests will introduce themselves a little bit. And then as I said, we have some questions prepared, and then we have the possibility to ask you questions. So Optimization for All is like a platform. It was founded by Christina, me, and several other people in order to push a little bit optimization. It should be an educational platform, so people should come there, get knowledge, but also find other people, like-minded people who want to understand optimization more and bring it to real-world application. So it's for students, but it's also for like managers who want to understand the technology. So for everybody in the ecosystems around optimization. We regularly do events. We have like an Entrepreneur Connects every 3 months, and also from time to time we invite experts to give lessons on important topics. And this is also one of the format where we host like bigger discussion groups with cool people in the optimization space. So if you wanna join also, not only for getting information, but also taking part, organizing events, feel free to reach out to Christina, to me, or anybody else in the team. Then we start with the first question. So to all of you, what led you to the path of building an optimization solver? And maybe you can also introduce yourself a little bit more in detail. I would say, Julian, maybe you'd make a start.
Okay, so, well, as far as HISE is concerned, back in 2018, my PhD student, Yvette Golubova, put together two outstanding LP solvers written by Edinburgh PhD students into software that would allow LPs to be defined and modified and solved. It was named HISE by a guy in Zeb in Berlin, where we both had work contracts. And it kind of established itself via the Mittelman benchmarks and its presence in interfaces like notably SciPy and Jump. And basically the rest is history from there on.
Okay, very good. Ted, you want to go next?
Yeah, I guess I have maybe a longer story. I've been doing open source for a long time, but I would say I was not maybe an instant convert to open source. So I mean, my work, the solvers that I currently work on started back in my PhD in the 90s. I was at Cornell and working with closely with a guy, Latsi Ladany, who I don't know if any of you have heard of him, but he was heavily involved in CoinOR in the beginning. The two of us worked quite closely during PhD. Batsi went to IBM, and IBM was where the CoinOR initiative was launched. And that's how I kind of got involved with the group of people over there that were doing open source. It was a little bit unclear back then, like what IBM's strategy was and why they were getting into open source. And so it took me a while to kind of become a convert. But then eventually, obviously I went full in, and I've been doing open source development for in many different projects for more than 20 years now. And I guess as I got further and further into it, I realized like it is actually something that I strongly believe in for myself. The sharing of knowledge. Basically, everything I do is open source, not just software, but you know, everything. There's not a word that I write basically that is not like somehow put out in the open. It's not for everybody, and I don't think that, I don't have the philosophy that all information should be free. I mean, it's up to the individual, but I strongly believe in it. And I guess I'm lucky enough that I have a career that allows me to do that and still get paid. And I realize not everyone has that. So, we can get into the philosophy of open source and why or why not to go that route. But for me personally, it's been very rewarding and also, of course, time consuming, but that's another story. So yeah, I got sucked in through the connection with IBM, and at that time I had my solver from PhD, Symphony. I made that open source, and I started working with CoinOR, and then I had a whole sequence of PhD students that produced lots and lots of open source code, and Lehigh let me put it all out there, and so yeah, that's kind of how it happened for me.
Cool. We see that you are a big fan of open source, and we also see in the guests that they are also a lot of fans with the hearts and the clapping here. It's a really nice introduction. Then maybe last but not least, Geoffrey.
Yeah, so I'm Geoffrey De Smet. I'm participated also in maybe 20, 30 open source projects, but there's one that took most of my time, which is of course the solver. Our solver, Timefold, started out 19 years ago, so in 2006. That's a bit older than Highs and a bit younger than CoinOR, I would argue, right? How it happened is I was an academic researcher at the time, and I saw somebody who present a presentation on nurse rostering and how he took a year to actually implement a nurse rostering case for a paper. Now, he actually just spent a few weeks, maybe a month, on the meta-heuristic algorithms, but he actually spent months and months on implementing the hard and soft constraints because it needed to be incremental. And I saw a way to use another open source project together with a known self-written meta-heuristics framework to put those two together and to actually solve this problem, and that would work on any scheduling or routing problem, right? I remember explaining it to my professor, and he just laughed at me. And so I proved him wrong. It took 7 years, but I proved him wrong. So 7 years in my spare time, I worked on it. And by then, people around the world started using it. That was 2013. By then, I was working for Red Hat, the famous open source company. And then we created a product around it, a support subscription around it. And life was good for 9 years until IBM acquired us. And then my project, which was called Optoplanner, by the way, we had a team by then. We're 5 people working on it full time, making it better every day. Always, bringing learning every year on how to make it better. And then, one day on the other, the project stopped. It was a dead man walking. So I created a company around it. I founded a company around it, Timefold. And it's an open core company. That means the solver is still open source, and we provide some services on top of it. And we're now doing that for 3 years, and we're 35 people, and that's where we are now, right now.
Yeah, really, really nice. Cool. Then we see we have really great guests here. So we will start with maybe the first more content-based question. So as all of you may probably know and see, machine learning is really, really big. And also if we look at the job offerings, but also at what's out there, what people are talking about, many of the data scientists often don't even know what is optimization. And one of the first steps is always to, if you want to get to know something, to play around with it. And why is open source really, really nice, because you can just easily install it and then play around with it and gather some experience. So the question is why has optimization, also it's much older than machine learning, has not seen the same adoption and also the same intensity with the people? Maybe Geoffrey, you might go ahead and the others can then jump a little bit in and add their thoughts.
Yeah, I do see that the solvers are adopted, right? So, for example, for Timefold, if you go in, if you appear in front of a judge in the UK, our technology is actually the one picking the judge, right? And if you are in the States, you will see that if somebody comes to install internet with you, there's a good chance that our solver was involved in that. But still, it's not mainstream, right? And there's many others, and this accounts, nor is any other solver, right? It's really because most of the planning still happens in Excel or in drag and drop UIs. But if you go into a couple of weeks ago, I was talking to a big airline, and they say like in reality, most planning is still happening on 4 big screens. Human planners with 4 big screen of them full of Excel, right? And the reason I think that's the case, and we're not seeing this wide adoption as we are seeing with machine learning and so forth, is really because um, there's a problem with fit for purpose. I think that's the main problem, fit for purpose, right? When you solve a scheduling problem, when you solve a routing problem, it must fulfill all of the hard constraints. And the business really doesn't care if one of the constraints is quadratic or if it has problem scaling. It just needs to work, right? And I have this thing that I say that, when you hear operations researchers talking about relaxing constraint, you know that the business is going to have a problem in the future, right? It's going to be, the project could actually fail because it doesn't do what it needs to do, right? And so business requirements aren't optional. It's not like dessert, right? So fit for purpose. I think that's the main goal here, right? And then there's 3 others. Ease of use. The code needs to be easy to read. There's time to market. It shouldn't take a year to put something in production. And there's scalability. It needs to scale to the needs. Now, what I don't think that's the barrier, I don't think the barrier is speed nor optimality, right? Things don't fail because they're not fast enough, right? Nobody cares about an optimal solution if it's not fit for purpose, if it ignores half of the soft constraints of the objectives, or worse, if you just break one hard constraint, nobody cares that it's optimal for all of the other constraints, right? So yeah, that's how it's.
Ted, do you want to add your thoughts on that? Or?
Yeah. I mean, I could probably talk for a long time about this about this question because there's so many facets to it. I think there's a couple of things. So over time, I mean, if you look at the history of open source and optimization, I mean, CoinOR, I think we could say was the first kind of effort to open source optimization. And the problem initially was 2 things. It was, low level code that was actually hard to work with, the build system was complicated. But the other aspect of it, which is important, is that there's this, the optimization solvers are always separated. You have this low level solver and then you have some kind of interface on top. It's like a modeling system or something. And for, I think, kind of cultural, historical reasons, those 2 things have remained separated completely. And in the very beginning, there were really not very many good options for open source modeling. So people were, having to use commercial solutions to do the modeling, and there weren't good interfaces to the open source solvers. And so the combination of those things led to, I think, at the beginning, kind of lower adoption. A lot of that has gotten better, but we still have a bit of a disconnect with, understanding how the ecosystem works and the fact that there are these open source modeling systems, but then underneath are solvers, and both things need love and care and feeding. And people tend to give a lot more love to the modeling layers because that's where they work, right? That's what they understand. And we've had a lot of trouble, getting people to see that, okay, there are these low-level solvers that also need support. And so that is an issue. But then, machine learning comes along, and I guess there are a lot of reasons for the success of machine learning. Yes, they've done everything open source from the beginning, which is a little different than how optimization developed. But for a lot of reasons that we could get into, there's a support for that development by huge companies that are very well funded. And so, I mean, in the beginning, CoinOR was doing pretty well because IBM was behind it. Once that support went away, it was much harder to find a way to fund the development of solvers. And I think now it's obvious machine learning, there are people, very well-paid people that are writing open source machine learning stuff. We don't have that, obviously, in optimization for the most part. And so it's a combination of factors. I think there's a lot more commercial interest behind open source on the machine learning side. There's not much commercial interest behind open source on the optimization side. I mean, most of the, highly utilized and supported solvers are closed source. So yeah, it's something that I think we can do a better job as a community of making our stuff easy to use, and I think also we're not very good at marketing, informs, and we've always had this trouble of like, what do we call ourselves even? I mean, people understand what artificial intelligence is, or they think they do. It's a very clear phrase, but operations research, it's like, what is that? What operations research? So we need to do a better job with that. But at the end of the day, we're academics who are not marketers, and it's just what it is. I don't know. It's a very difficult thing to overcome.
And that's what we are trying to do at Optimization for All. It's basically
Yeah.
marketing.
Yes,
So,
and I
yes.
appreciate that because you're much better at it than the academics who are writing code and just want to stay in their office all day and sit at the computer.
Yeah, we are all working together. But I completely agree with you both. I mean, maybe a small anecdote. When I started with optimization, like 12 years ago or so, I also worked mainly with commercial solvers because had like a one-click install, pip install Groby, for example, and you could work and model, and there was a lot of examples out there. And I remember with Skip, you needed to do some crazy Linux installation, and just the barrier to entry was much higher.
Yeah.
Building from source is so much fun, right?
Yeah. Yeah,
I
maybe.
mean, it's gotten better, and so now there are, Conda packages and things for the CoinOR tools, but it's taken such a long time that it's already kind of like too late,
Yeah.
It's never too late,
Yeah. Yeah, it takes time, but I mean, if maybe the installation was super easy, maybe more people have played around, and then you get more and more people later because maybe
Yeah. I
when
mean,
they're students 10 years ago, now they're in the jobs where they can use the technology if they remember that there
Yeah.
was optimization.
clearly part of the machine learning thing is just, it's so easy to just grab it and use it, and it's all open source, and that hasn't really been the case for optimization until recently. Now it's better, but
Yeah. But as I agree also that there are many different reasons. So I would say one is a easier installation, but I also see that machine learning has I find also from the application side a much easier barrier to enter. You basically need just the time series itself, and you can predict in like 3 lines of code, and then have something. With optimization, you need endless workshops and iterations to get it right, because if you forget one constraint, it suddenly looks really off. So there is a lot more effort also involved to get something right. Yeah.
Yeah, and also the amount of data you need to input, right? So, for example, if you go to ChatGPT or something like this, you can input your problem like 2, 3 lines. There's no way you can, put your input for scheduling problem in 2, 3 lines, right? If it fits on 5 pages, you have a small one, right?
Yeah.
yeah, I mean, I think the optimization community has also been, I guess, like from a research standpoint, focused on the mathematical, technical details of the solvers and proving optimality and all these things. And obviously, to make a quote real solver like what Geoffrey is doing is a whole different thing. I mean, you may not care that much about the details. You care about you care a lot about the interface and about being able to produce something useful, but whether it's provably optimal may not be that important. And, academics just don't all, want to write papers about those kind of solvers. They want to think about the mathematics. I mean, I myself am one of those people. So yeah.
You need both, of course. You need, you need a good solver, and you need to make it easy to use, right? It's when these things clash that it becomes interesting, the discussions.
Yeah. So
Yeah, we see in the chat very interesting discussions. Everybody's saying opinions. So thank you everybody for sharing your opinion. So it's good to see, like for me, interesting to see what everybody thinks, not just us, the people on the screen. So thanks for sharing.
Yeah, great. So then,
Christina, could you put my video back, please? Because it would appear that I'm not participating because I can't get my video back.
Okay, let me check. Well, maybe Prajit, can you check so I share the next question? Or Julian, do you still want to answer to this question? Or
no, I'm just saying that I'm trying to start my video and I'm getting a message that you stopped me from doing that.
Okay.
Christina, could you please make Julian Hall co-host? That way he can start his video.
Okay.
Yeah, sorry.
Because it all crashed. It all crashed on me, which is why I've had to come back in. I guess all I can add to the previous discussion is that I don't know very much about ML, so I can't really comment on that. But Hives is certainly very easy to install and get going. You just pip install HivesPy and that's it.
great. Then, yeah, let's move on to the next question. Julian, maybe to you. So the second question is about so open source solvers and commercial ones. And this question also sparked like a debate under some of the posts I saw, and many people also argue that if you have like a business critical application, why should you trust yourself on open source? It could fail, the people retire, and nobody does the maintenance. So what's your view on this? So for what kind of application would you say you should use like an open source solvers, and how do you actually build and gain the trust that commercial one have?
Well, I think given the track record of open source optimization software and the scale of the commercial companies, it's not surprising that we're not going to get the same level of trust. So I can't see it ever really happening. All we can do is be as professional as possible in terms of security of support and development, and not put ourselves in the position of, well, if one person retires, that's the end of it. As and when I retire, I've got young people ready to take over. Clarity of documentation also makes you look much more trustworthy, but that's hard to invest in.
Do you want to add on that, Geoffrey?
Yeah. Well, there's multiple. So I think the most interesting thing is, of course, you build a reliable business model around it, right? There's multiple ways to run an open source project, right? And the path we took, and I'm not saying that's the only path, but the path we took is build a sustainable company around it with a reliable business model. Be clear about that, what that is, of course. And then, we have a dedicated solver team, and we have it's the heart of our company, and we have a number of models teams who work directly on the solver, who know the solver, who can also participate in improving the solver. That's how we constantly improve the solver. We get a lot of feedback back from the community on to improve it. And this is something I think is an advantage for open source solvers, right? Because a lot more people try it out. Like in our case, we have 5,000 unique IP downloads per month, right? That's 5,000 projects running it. And that basically means that any bug gets spotted immediately. Last month was a bit embarrassing for us. We had 2 coming out of the community, and we had to fix them quite quickly. So that's, I think, how we can build trust, right? Fix bugs quickly. And the other thing is, of course, build an open ecosystem, have partners and have other companies who build on top of us. That's hard, and look for collaboration potentially with other solvers, right? We only focus on scheduling and routing cases, for example. We don't do many of the cases I would argue that Highs or CoinOR is doing. And so there's many hybrid cases where you might want to use both of these or together with other open source software. And the last thing is I have seen things what I would call bench marketing, and I think we need to stand up to that. It's not real marketing. It's just not real benchmarks. It's marketing disguised as benchmarks, and I think we need to stand up to that and just provide open benchmarks with the source code available that anybody can reproduce on their machine and get reliable numbers on what solver has the best results.
Yeah, I guess I would say like it maybe the how to build trust is not quite the right question. I mean, you build trust by having a well tested and debugged solver, right? And showing that when people report bugs, you fix them, and that's how you build trust. I mean, we know it's not that we don't know that, but you need resources, right? I mean, this is the this is the issue. I mean, CoinOR has no real resources behind it right now. I mean, I try to respond to things as I can, but I'm maintaining many solvers, and it's difficult. And I think there's a question later about funding, and we can get into why there's no funding. But yeah, it's an open source project. I guess I would say, as far as publication and papers, you mentioned. I mean, I personally would like to be in a world where commercial solvers are not used for research because they're black boxes. And like, as far as trustworthiness goes for research, I don't really, I don't know if trust is the right word, but when you're using a black box in research that you don't really understand and have no idea what's going on inside it, it's a little hard to say that you're doing good science, I guess. So for me, open source solvers, a big argument for their existence, and what CoinOR argued from the beginning, is that you need open source to actually do research, because you need to have an open ecosystem all the way down to the bottom to understand what's going on. So, I mean, there are good reasons why people build on top of Gurobi for published research, and in a lot of cases it's fine, it's justifiable. But I guess overall I would say that on the side of being able to verify what's actually going on in the solver, I would put more trust in the open source.
That maybe leads also a little bit to the third question, which is basically that open source, you need kind of like a critical mass. It cannot depend on one person. You need users, but you also need like contributors, developers. So you need to reach like a critical mass and also then like a life cycle when people retire, new comes, and this is also how you build trust. What has worked for you to build this community? Do you have any kind of strategy, or you just do stuff, or it happens randomly? So maybe you can go ahead, Geoffrey.
Yeah, so we dropped the ball on this a couple of times, right? So what we actually did is, so we've done good things too, right? So we've answered Stack Overflow questions, and that basically means anybody who had a problem and they asked a question, we answered it, and we learned a lot from that. But the problem with Stack Overflow was there was no discussion, right? So people didn't get really involved. There was no real-time chat. So recently, with Timefold, we have a new community lead, Tom Coles. He might be here in the chat, and we started a Discord server, and this is changing a lot with him joining us. And with the Discord server, we now have over 100 users, 100 members there, which is not a lot yet, but in 2-3 weeks, I think that's a good number. Now, what's interesting is over the years, we've had more than 600 people actually contribute something to the code. But these were drive-by contributions. That means, there was a null pointer exception somewhere, or even a mistake in the docs, or like one feature they were missing, and they added this, and they were basically just scratching their own back. Got into the release, problem was solved, went into production, and we didn't see them anymore, right? We didn't really have people who stick around, right? And that's where we dropped the ball a little bit. And when we did, we recently hired our #1 contributor in the community, so that's also so it's a little bit our own fault too, of course, right?
And Julian, would you like to add something?
Yeah, well, we built our community by engaging with developers of interfaces and modeling languages, who then kind of recognized that we were the best game in town in open source, and so therefore they wanted to offer us as their default open source solver. So in terms of users, that's how we built things. In terms of developers, it's very, very hard for people to contribute meaningfully to optimization solvers like MIP solvers and LP solvers, because it's highly technical. But certainly in terms of the interfaces that we support, and we've had lots of contributors to that over the years.
Yeah, I guess I would say that we have not been that successful at CoinOR in engaging the community in a sense. I mean, it's actually always very hard for us to tell how big and the community is, and who is that, because once you put open source out there, you realize like you can't really control it, and like it gets distributed through so many channels that you have no clue. I mean, it can be installed on Linux distributions, with an apt-get and whatever. So I mean, you really can't tell who's using the software except by who comes to you with complaints, or very, very seldom we get compliments, but sometimes. So yeah, I mean, we have a sense of the community, but we honestly could have been doing a much better job engaging the community if we were focused on building something like what we have here, the optimization for all. But again, we're like, people with day jobs and very little resources. So we never really got to the point where we could focus on the community building aspect of it. And, as Julian said, it's true. It's very hard for people, and it's getting harder all the time with the lack of training of young people in C++, to have someone come along and just contribute to a solver. you kind of have to write a lot of stuff still in low-level languages to get performance, and so it is very, very hard to engage people in doing actual development, and that's a big issue.
Yeah, that to your point that you don't know how many people are using your open source software, that's very recognizable, right? Most people that use the software don't even talk about it. They don't write anything on the internet. They just, they solve their problem and move on. I sometimes have that I come at I regularly have that I come at a conference and people start telling me like, we've used it for X, Y, Z. And I always ask them, why don't you do a blog post? And they always say, yes, I'll do one. And then, but rarely I see a blog post, to be honest.
Yeah.
It takes time.
Yeah, I meet people all the time that tell me they use this or that solver way back in the day, and it's like, oh, okay. That's nice. But yeah, it's hard to know what the community really is. Yeah.
Yeah. Yeah, and also with this blog post, so what I see is also that many of the successful cases also don't really want to talk openly about it because it's often their core asset. And also I talked to one guy and he said, yeah, we wanted to publish it, but then they feared that the customers of theirs say, oh, we are now 10% more efficient, so you don't have to pay us so much money. So it's a little bit tricky also to tell the successes of optimization. Yeah.
I think that extends to not just the open source solvers, but also the commercial ones, but it's very recognizable. We are at the heart of the operations, right? And we are competitive advantage. And it seems like a good problem to have, but it's a very serious problem. Our marketing department actually made videos specifically to point out that our customers don't want to talk that they use about using us. And yeah.
Mm.
And so, Geoffrey, you said you see also who is contributing. Do you have some kind of not statistics, but just from your view, what kind of people are there who are really good at contributing and doing much, and maybe to know where you need to focus your efforts on? Have any kind of insights on that?
So there's two types, right? You can look at contributors or you can look at users. Users wise, you get very limited statistics. So we are a Java solver. So our open source solver is mostly for Java users, Kotlin users. We do have a Python port right now that's being maintained by the community. And what we see is the numbers you get from like Maven Central or from like PyPy, it's very limited. You don't really, you might see where they come from which country, but that's about it, right? I do see there's things evolving there. You can get a little bit more information these days. But on the other hand, from the contributor side, like I said, most are drive-by. They, like Ted already said, they're not going to dive in and implement something for 3 months in the solver that adds a new feature. And the problem is that these things that we're writing are incredibly dense, just like a diamond. It's if you pull, it's like language design. If you ever looked at videos around language design of like Java or Python, you change one little thing and it affects everything. And so it's not this typical horizontal application where you can just add something on the side and you add another UI and you add another database connection and you're done. No, every feature affects every other feature. And that means that the barrier to entry to get started is very big, and that makes it really hard to get contributions.
Mm-hmm.
Okay, thank you. Maybe it's thanks for answering the questions. Maybe we will give our audience the chance to ask questions, because I monitor the chat and I see there are not specific questions, but everybody shared that yes, with open source, problem is scalability. So this kind of issues. So if anybody wants to ask questions, please put your camera and your microphone and go ahead. I can, so everybody's sharing the solvers they are using, what are they using it for? And I think Ruben said that the problem is that the companies, they don't want to invest in something which we don't know if tomorrow is there. So that's the problem, that even the product is good, but yeah, is it good today, but what will happen tomorrow? Whereas commercial solvers, they offer this certainty. So that's a very good comment. Anybody else wants to ask a question? Yes, Hadi?
Yeah, sure. Thanks for this informative meeting. I have a question for a UI for like solvers. We have like mathematical modeling and we have solvers, right? And mostly mathematical modeling has its own name, right? Mathematic. But how we can like make this part fancy for end users, those business managers or specialists that they don't have a sense of mathematics and those type of things in a better sense, like in a UI drag and drop. Do you have any idea, any best practice or any experience from industry that you can share with us? Thanks.
I'm happy to start for this question. So from our side, we spent actually a lot of effort for our quick starts to give them a pretty UI. So interesting story. In the original times, we were using this old technology. It's called Swing in Java, where you had this UI for the examples and you had this old style buttons. And then we always got back the feedback like, you should really drop that. And I said, like, it's not important, it's just lipstick. The important part is the solver. I was wrong. It took me about 5 to 10 years to realize that. But when we started doing the quick starts and we made them just a web UI, REST interface, you pick one of these up, so you can actually show them to your manager. Look, this is how you can solve, I don't know, a flight crew scheduling problem or something like that. Maintenance scheduling, we have examples of those. And they actually see the things moving and they can say, okay, can you now add this or that, make this or that change, and you can see it again. That's how you can have a conversation with your business users. And so it is critical. And yes, it takes away time for building a better solver. And you have to balance that.
Yeah, I mean, I think that's also where it's harder to support development of things like that in an open source model. I mean, that is, in a sense, that's where the money is to be made, is taking open source and, making it work underneath an interface that's specific to some particular use case. I mean, that's the problem, is solvers can be general, but the way that you use them is very specific if you want to remove the mathematics from it. And that is not easy. So I think what I foresee is that it may actually become possible to do this in a much easier way with machine learning, right? I mean, already there are some open source systems for having an LLM produce a mathematical model underneath from an English description, which of course is not foolproof in any sense, but it may become possible in a relatively short period of time for an AI to generate an interface and, for some of this to be somewhat automated. But, who knows if that will come to fruition or not. It's still, that's where to get users, you have to have that part. And that's where the people that are, like Geoffrey, that are developing this stuff commercially, that's the important thing. And having it all open source is a difficult thing to imagine.
Thank you. Anybody else wants to answer a question? Antonio, yes, please go ahead.
Thank you, Christina. So, guys, congratulations on the open solvers. I wish that they had been as mature as they are today, back when I was doing consulting, because there were certain problems that were relatively easy, in my opinion, to do, and they were using open source solvers that couldn't solve them about 5 years ago, but I know for a fact that that's different. So I think that that is excellent. And one thing I need to say is that there are a lot of machine learning practitioners that are in love with open source tools. And like somebody said in the chat, there are many more machine learning practitioners than there are of us or practitioners. And since they like open source, perhaps that's an easier way to get let's say, the word around. And documentation and the like is much easier to create now with AI and the automate the API. So I think that we're going to see a qualitative jump in documentation and the like in the next few months. So keep up the really good job. And I usually go for an open source solver before going to a commercial. So please keep it up. I'm a happy customer here.
Thank you, Antonio. We have Mihir raising your hand. Please go ahead.
Yeah, just a second. Yeah, so my query is with respect to, so I'm using an MIP problem for energy scheduling and has almost 1 million constraints. So, and the computational time is humongous. So how can we break down for a problem like this? Because again, it's not easy to break the problem, considering that there is a sequential year-on-year generation that is linked together. So I can't break the problem. And the second thing is, let's say when you are trying to create a constraint, let's say within a constraint, I can't write a minimum of 2 variables or a maximization of 2 variables. And that's where the you have to use auxiliary variable and create a big M and things like that. So how can you, let's say, bring down this complexity while writing the OR problems?
If I can take this question, in our solver, you can write min, you can write max, you can write if statements, you can write a VAT calculation that's 5 pages, has a 5-page business analysis on how the if-else statements work with whatever formula you want in there. So we took a very different design. However, that does imply that our solver is for scheduling and routing problems, right? So I don't know exactly what I don't know exactly what problem you have there, but if it fits in there, you'll see you can do all those cases. As for the 10 million constraints, that again again depends on how you model it, right? Because what you can actually do. So, for example, just to give you an idea, most of our models, even our high, we sell some proprietary models for specific planning problems to very large enterprises. And those problems typically have up to 50, 60 constraints. 60 constraints. Yeah, they deal with tens of thousands of employees and things like that. So what actually happens is we count the constraints differently. We just count the types of constraint, not the actual, potential matches. And the reason why we do that is because we never create all of the matches. We lazily create the matches that are actually that the solver is actually running into. And that means that it doesn't go out of memory, that it can scale much better, and that for the same problem with the same data set with the same constraints, you don't have that 10 million instances problem or that 10 billion instances problem.
Okay, thanks for the.
So we have a question for Julian. I don't know if you saw it, I'll read it. How hard was it to get an open source solver project with NESO, UK National Energy System Operator? And I think the continuation was that, is there demand for such project? But I think the question is, well, how did you get their trust? How did you convince them that,
I just got approached by them, and they invited us to tender for this project.
Okay.
They knew that we had the expertise to do it, and a few others would. So they kind of chose us.
Wow, that's good. So you're famous in the UK. Everybody knows you. Or was it like who from there knew about you? Like, was there
the people who contacted me in the first instance I had never met before, but I mean, we have a presence on LinkedIn, and who knows and we have a presence in the energy systems ecosystem as well. So I don't know. I mean, that's networking is what happens, and I don't know.
Yes. Okay, yeah, cool. Another question. What do the speakers think about the high number of open source solvers available? Is it not a problem? In the ML community, they have only a few libraries framework. In the OR community, the list of solvers, our libraries frameworks is very huge. Therefore, a lot of efforts are scattered, which might be one of the main sources of lack of adoption. What do you think about this one?
Well, I don't think there's an awful lot of worthwhile optimization solvers in open source. And I don't think there's an awful lot of the solvers that are visible are actually being developed in any meaningful way. So I think, it's an illusion that there's an awful lot available, whereas really there's only 2 or 3. in linear optimization anyway.
And I think if you go into the machine learning world, you'll find thousands and thousands of dead projects of, you know, it's good that these things are tried, right? And some of them become a full big project, and others die after a few months. You know, sometimes even brilliant ones, because the labor of love of the open source developer who starts it sometimes cannot continue, right? They get kids or something, and they have to, you know, they don't have time in their spare time anymore, right?
Okay.
Yeah, I mean, I think I have thought a lot about this, and you know, so when Zib started the skip effort, of course, I know all the guys at Zib very well. But I mean, my first thought was exactly this, like, okay, why don't you just join CoinOR? Because then together we can build something really great. And instead we have half and half. But over time, I guess, yeah, there's just a lot of practical reasons why people feel that they want to develop their own solver. I mean, a lot of times I think people start something new simply because they got funding, and in order to get the funding, they had to promise to build something. And if they said they're going to just use existing open source, that wouldn't have, you know, gotten them, they wouldn't have gotten the money. So, you know, there's practical things like that, which honestly, I think drives an awful lot of this fracturing. Is everyone needs to have something to put on their CV that says, I built this from scratch. And I mean, it's, what can you do about that? You can't really stop it. It would be, in a sense, like it would be a better world if we all got together and just worked in one big community on one thing, but it's just not the reality.
You also have not invented here syndrome, right? What we build ourselves, we can do better. I'm right.
Yeah, yeah.
We encounter that a lot, even with people who have scheduling, you know, companies who have scheduling problems, and who are like, okay, we might use your solver, or we just might want to invent our own meta-heuristic algorithm specifically for our planning problem, and we are sure it's going to work better. And yeah, you usually see them back after a year or so. It's
And maybe in 5 years, all your three solvers merge, and we have like one.
I mean, there's a good reason sometimes to throw away the old and just start from scratch, because sometimes there are design decisions that are just very hard to undo, and yeah, it's better to start from scratch. But other times, you know, it would ideally not be the case, but
3 years ago, we replaced our score calculation engine with, which was a rule engine at the time, an external project with our own, and our download size was reduced by 60%. So yeah, sometimes it's a good idea to restart from scratch for certain parts.
Yeah, I mean, that's how we got our MIP solver, because Leona Gottwald knew that skip needed to be rewritten in order to be more performant, and they wouldn't let her do it. So when I offered her the money to do it, she wrote it from scratch herself for highs, and it's now a lot better than skip for solving MIPS.
But the nice thing is your users don't really notice, right? Because you switch. It's something underneath that switches just goes faster, and you know that makes transition much easier, right?
Yeah. Somebody's asked how we got names for our projects, and since the person who named Highs is on the call, Highs is named after the initials of me, Yvette Galabova, Huangfu Chi, and Lucas Schork, who wrote the original PSOLs, and it was Matthias Miltenberger of Zib who came up with the name. So thanks, Matthias.
Yes. You want to answer also, Geoffrey? And that.
So, Ted, you go first.
well, I mean, I've had a love of acronyms for a long time, so I have many solvers with kitschy names, and you know, so I've always enjoyed coming up with the acronyms. But it's a little bit of a lost art now, because it's too easy to get an LLM to just generate acronyms and things. I mean, so yeah, anymore I'm like, okay. It's a lost art. Designing acronyms used to be hard, now it's easy.
For us, it's a bit of a longer story. This is our fifth name already. And by the way, if you ask how do you grow your community and how you build an open source community, don't change your name 5 times. That's like rule number 1. And the first one was TASERI, which was an acronym for Taboo Search Rule Engine Evaluation that lasted for about a year. Then we had Rules Solver and Rules Planner because we were a sub-project of a rule engine called Rules. Big tip there, if you want to sell to businesses, don't call your stuff Drools. That's really not professional, so that doesn't work. Then we had Optoplanner, which was a good name. The only problem, the P was capital, and people started writing me Octoplanner, Optiplanner. Nobody could seem to spell it, right? And then we had to change it because we didn't own the trademark. Well, there was no trademark, but we didn't own the domain name, and we founded a company. And that's we ended up with Timefold, right? Because we have a nice thing around it. We fold space and time. Sounds great, right?
Oh, wow. That's very
By,
deep.
by the way, I mean, a little anecdote. CoinOR only has the -OR part on it because there was another project called Coin already, and they owned coin.org. So the coin-OR thing, which is now like, I guess nobody questions it and it's pretty well established. But in the beginning, we were like, oh, CoinOR, it'd be much better to be just coin. But yeah, that's the reason for that. And Symphony, my first solver, I chose that acronym before realizing that IBM actually had a trademark on Symphony because they had a spreadsheet, I think, or something that was called Symphony. And when I took the software to CoinOR and exposed it directly to IBM, I was like, oh, whoops, I'm using their trademark name, but oh well. They never complained about it.
Okay, thank you for the answers. Yeah, that's good to know the history. Good question. Thank you for the question. We are a bit over schedule, so who wants to still stay on? I think we can still continue for maybe 10, max 15 minutes. And maybe we'll take the questions for the people that raise their hands, and then I can go back to the chat. So Samuel, you want to ask a very quick question?
Hi, yes. Thank you for the conversation so far. It's been very interesting. So this is Samuel. I work for as a consultant for an airline, supporting crew scheduling and planning. And I use optimization for some initiatives that we have to improve our crew experience. I think that I just want to make a comment on this, but this is not related to the question, is that we do care about the efficiency with respect to the runtime of our applications, not because we want to have a solution that we can retrieve very fast, but because we have to follow different and lengthy processes from the development to the deployment of our products. So, for instance, in this conversation, I mentioned continuous integration and continuous deployment. So our model has to be tested multiple times before deployment, and it has to be improved in case we find a bug. And that's why we care about efficiency with respect to runtime. And this efficiency might be compromised when the problem grows very fast. If you have a lot of crew members or flights, or just keeping it within the domain in the airline industry. But my question goes more towards what I had to do during my PhD studies, and I was working on resource allocation with respect to fairness. And this growth within the problem's size was not necessarily because of the number of constraints that I was actually inputting towards to my problem, but also because I was dealing with some nonlinear aspects of the problem. For instance, I was dealing with some natural logarithms that I was using in the objective function. And then what I chose to do with the solver that I was using, it was a commercial solver, is that I was linearizing it with the functionalities they offered. So general constraints, linearizations, and although they offer some ways for you to tune the way that the nonlinear functions are linearized, that was for me creating some sort of a black box, because I couldn't tell how or if at all these functionalities were the ones causing some weird behaviors when I was retrieving the optimal solutions. So to my question is, another way that the problems can grow large is because of some complexities that you input into that, such as these linearizations. How can the open source solvers offer some or greater transparency in these aspects if they do offer functionalities such as linearization features, for instance, natural logarithms, exponentials. So yeah, I think that's the question I have. How can they offer more transparency with respect to commercial solvers in order to build trust as well?
If I can take this question. So first of all, I don't think you can actually linearize a fairness function. It is naturally quadratic if you do it correctly, because fairness means that you deal with the person or the machine or the load that is worst off first, and then with the second person worst off, and then with the third person worst off. There's no way you can linearize this. And if you do, write it down, because I'm very interested, right? So we actually built a fairness function in our solver, which you can use directly from the constraints. And you can also, it's open source, you can look how we do it. We even have a video that's explained how it works under the hood. It's basically a sum of the squares and then a root on top of it to make it, to normalize it against the other soft constraints or hard constraints, right? That's one. And I don't think this applies to just for open source solvers. It's for commercial solvers too. You need to explain how your functions work. You need to document that, and it needs to be clear.
Thank you.
Okay. Sorry, I don't know how to pronounce Wakwar. Do you want to ask a question?
Yes. Well, first of all, thank you so much for organizing this. It's a very interesting discussion so far. I have a very specific question to Julian, and that is related to GPUs. So I know that I know Harris also came up with the PDLP implementation of the PDF implementation in for their solver. I was wondering, how does where do GPUs fit in as such, into the broader in broad class of optimization problems. So any comment there? Just wanted to hear opinion.
There is some scope for them in continuous optimization. At the moment, for solving integer mixed discrete problems, I really can't see them having any real use. There are, with the first order algorithm, there's severe limitations to it in terms of the accuracy of solutions, but it's new and exciting, and we'll just see how it goes. But I wouldn't throw away your CPUs yet.
I see. Well, yeah, interesting. Well, thank you.
I fully agree with that. Some of the reports on one particular article I have in mind is questionable.
Yeah, I mean, I don't know. NVIDIA's really pushing this stuff right now, and I think they're probably doing some interesting stuff. But yeah, I mean, I'm not an expert in GPU, but I guess in my mind, it's kind of like, okay, you have a way of parallelizing matrix vector multiply and simple low-level operations like that. And if you can boil your algorithm down to that, then GPUs are going to help you. And if not, then not, So I think you just need to understand what GPUs are actually good for, and then ask yourself, is the algorithm that I'm trying to implement able to be boiled down to a sequence of these things?
They do a bit more than that, Ted, because NVIDIA's got a sparse Cholesky on a GPU now. And although some of the commercial companies have looked at it, others have written them for themselves because it's got limitations for application to interior point. But it's not impossible that it could be used for interior point.
Yeah, I guess I'm certainly not an expert, but it seems like GPUs can only do very simple parallelization.
They can, but the fact that it can do sparse Cholesky was quite a game changer for me. That really did impress me. So we just don't know where it's going to go. the idea of doing updates of value factorizations required for simplex on a GPU, that may be rather more difficult. That may be a long way off.
GPUs were a game changer for machine learning, right? Because they could parallelize it. I can't say about continuous optimization, but about discrete optimization, I've seen not a single case where it actually makes a big difference, or where it actually competitive.
I mean, I actually have some ideas about that, but they require just completely rethinking the way the solver works, like just, throwing away the way current MIP solvers work, because MIP solvers are optimized for the kind of system they were developed to be deployed on. They're not optimized for GPUs. So, but you could, if you had GPUs for free and you really were, had a motivation to do it, you could probably think of redesigning the whole thing so that it works with the GPU. But it's a lot of effort.
Okay, thank you for answering. So thank you everybody for joining and staying so long. We have a very quick question. I think it's a good one to end our great conversation. So somebody is asking, what is the best way that we can contribute to any of this open source project? Do you prefer having regular donations so we can fund the development, or code contributions, reporting of bugs, partnering with companies? And the person says, thanks for maintaining this project. I've used all three in different times. So what's the best way that the community can support your work?
For us, talk about the use cases that you use it for.
Yep.
Okay, Julian agrees.
Yeah, if you use our stuff, do that. Just doing that, just talk about we use it and we use it for this and it works well for us. And this worked and this doesn't work, that's fine. That's how we learn how to improve it. But that's a lot for us. If you want to go the next step, that takes a lot more effort. Yes, contribute a quick start. Start with that. That's a really good, easy way to start contributing. Or if you're very interested, or if you're very ambitious, try porting us to another language. There's a couple of people now trying to, improving our Python ports. It needs a lot of work. So if you want to go really far, definitely take a look at that. It's very promising, but it's also very challenging. It's a really great way to make a big difference. Yeah. Don't worry about donations. Just to give you an idea, there's this open source project called Bootstrap that is used by millions of people, and they have about $9,000 per year in donations, and they actively ask for donations. So donations will not, in reality, donations will never be enough to fund a project. Software engineers are just too expensive.
It depends who's donating. I mean, we've had best part probably about $750,000 worth of donations, which have seriously made a difference to Highs.
Okay.
If you can give me the connection of that person, I'm more than happy to talk with them too. Just kidding.
Yeah, I mean, for CoinOR, I guess there's always things to do, and volunteering is always appreciated. But we've also not been that great at managing volunteers over time, because that also takes bandwidth, and bandwidth is always the issue. But we talked about it being hard to get into the depths of the solvers and do development there. But there are many other things that I spend time doing, like managing the Conda recipes and things that are just not where you don't even need to really understand the solvers that well to contribute. Conda, for anyone who's tried to use Conda and develop recipes, is like a huge time hole that you can disappear into for days and not really understand what's happening. So yeah, I mean, if you have any expertise in any sort of development stuff, we can probably put you to work if you want to contribute. So.
Okay. Julian, you also want to say? Because it seems you have money, so what else do you need?
Well, it's very useful being somewhere where they, an academic institution where they recognize the impact of our research. And that's why the School of Maths pays for a full-time position, open-ended position for our software software engineer. So Yvette is fully funded into the future to maintain the build and things for Highs. So you need people working full-time, and I can work pretty much full-time on Highs as well. So yeah. Get big users to pay for PhDs if you're in the academia. I've got 2 or 3 that way. Yeah. Show yourself to be useful. Get yourself used by big people. MathWorks is funding a PhD because they use our solvers in MATLAB.
Okay, thank you. I see there are still some questions, and I'm very happy we had this a lively chat. Thank you everybody for joining. We'll also scan the chat because a lot of people shared links. So we are going to take all the links in the chat, or maybe some opinions, some questions, so we will send them to you in case you want to have some inspiration ideas, because some people also gave some good suggestions. We're going to close the session now. Thank you everybody for joining. It was a great session. I think we'll have to do it at least once a year. And see how the open source solver community or projects develop. If you want to have a closing remark, something you feel that we didn't touch in the session and you want people to remember you by, now is your chance. So if you want to do that, and then we'll close.
From my side, I would just like to point out, if you're looking for a solver, go to solver.timefold.ai, put it on the chat. The reason is, if you just look for Timefold, you end up on our main page, which is which is for the enterprise models, right? So make sure you go to the right page.
Yeah, I guess I just want to thank the organizers for inviting me here. I mean, another way to contribute is to do this kind of organization, because honestly, we never had this many people engaging in any CoinOR thing that we've ever organized. Like, this is the and that goes again to the fact that we're not marketers. We just try to do our best. But this kind of thing actually, I think, provides much more exposure than we usually get when we're left to our own devices. So I want to thank you guys for organizing this and doing what you're doing, and keep it up.
Okay,
Thank you.
Yeah,
fully agree also.
Julian, you also want to say something, or I interrupted you?
No, in closing, no. All I would say is that I realize there's all sorts of interesting questions in the chat, and can we go through that afterwards and answer them, and will people see them? I just don't know this Zoom business.
Yes, we'll scan the chat for the questions, and maybe I'll send them to you, and you can maybe choose some of them to answer. So we'll make like an article of it, and then we will share it.
You can
I
set
think
up
it's
some
a lot of
meetings.
valuable information. Yeah.
Yeah.
Okay. Good. Thank you, everybody. Have a great evening, and we'll see you at the next
Thank you,
event.